These videos are for March 10th if you're A day. We did this on March 10th. If you're a B day, we didn't do this type of lesson. We did something different to make sure that you had the time that you needed. I went ahead and did some of this stuff already, and I'm going to explain some of that. If you haven't determined how to figure out asymptotes, you need to go back, watch the previous two videos, or watch, click on the previous post, watch those two videos so you know that. I went ahead and did the first one, kind of essentially the essential pieces on my own, and then we're going to see how to graph it. But we say that, first off, I wrote this in standard form, so always highest exponent to lowest, so 2x plus 3. We also know x can't equal -1, nothing cancels out, so we have a vertical asymptote of x equals -1, and because the degrees are the same, our degree in the numerator, if it's just x, our degree is 1, same thing in our denominator. Again, we're not looking at the leading coefficients, we're looking at degrees. Since they're the same, we divide our leading coefficients now, 2 over 1, or just 2. Now, how do these graphs behave? I'm going to go out on my scale 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Depending on what day you were, we ended up looking at x-intercepts and y-intercepts. I'm actually going to scratch this out if you're just watching this. It's a good concept. It's a good thing to know. But I don't want to spend too much time talking about that in this video because there's other ways we can do it. But let's go ahead and draw our asymptotes. We know we have a vertical asymptote of x equals -1. So it's going to go through x equals -1, our asymptote. We have a horizontal asymptote at y equals 2, so we go to 2 on the y-axis and draw a horizontal asymptote. So those are our asymptotes. But now we have to figure out what's happening in this section of the graph to the left of our vertical asymptote and in this section of the graph to the right of our vertical asymptote. So how can we do that? Well, really all we need is one point. If we can figure out if it's up in this area, well, then we will know it's not down here due to it having to pass the vertical line test. Similar thing here. If we know it's in this area, we're fine. Or if it's in this area, we're fine. So we have to do some work for that. And the way we can do that is plot points. So for example, we have to figure out, let's start with the left of this dotted line. So let's pick an x value, a value that we can plug into our function that is to the left of our vertical asymptote. Makes sense to just go 1 over. So let's go -2. So if I plug -2 into the function, two times -2 give us -4 plus the 3 would give us -1. -2 plus 1 would give us a -1. So we get f of -2 is equal to 1. Which means that's our ordered pair. At the value, when x equals -2, our function's value is 1. So it's going to go through this point. What's happening here is if our function goes through this point, it doesn't make sense for it to go like this because it can't cross this asymptote. It doesn't make sense for it to do like this because it can't cross that. Same thing there. So what's happening is it's going to go through this point. I'm going to make that point bigger. But as it goes this direction, it's going to go down and get close to this asymptote. So it's going to do something like this. And same thing in the different direction. It's not going to go up forever. It's actually going to tail off and tend towards this asymptote. Like that. And that's all we need. All we need is one point on this side to figure out how this function behaves over there. Let's look at it on this side of the function. Here that's at -2. If we go on this side of the function, 0, that seems like an easy one to plug in. If we plug in f of 0 into our original function, two times 0 gives us 0 plus 3 over 1, which is just 3. So that tells us that our function's value at 0 is 3, so it goes through this point, and it's going to have a similar shape. And that is what our function should look like. Something similar. So essentially what we need is our asymptotes and 2 points, one on, well, in this case, one in each section split by our vertical asymptotes to determine how the actual function would behave. If you have questions about this, please ask me through Remind app, things like that. I'm going to go to the next one, see how we can graph this one. I went ahead and factored it. So we have a difference of 2 squares here, so it'd be x minus 2, x plus 2. This factors in this way. From here, we know that x cannot be negative 2, x cannot be 3. But we know that the 2's cancel out. So our actual function, well, our simplified function will be x minus 2 over x minus 3. What do we know already? Well, we know because these cancel out, our function is going to have a hole where x equals negative 2 because the 2's cancel it out. Because the 3 stayed, x minus 3 stayed, that means we have a vertical asymptote at x equals 3. Vertical asymptote. And because our degrees are the same, in our numerator we have a degree of 2, and our denominator a degree of 2, we can divide the leading coefficients. And if we do that, that means we have a horizontal asymptote. At y equals 1 divided by 1, or just 1. So this is what we know about our function. And pause there, let you gather it. Or if you want to pause, you do that. I'm going to scale it 5 again. 1, 2, 3, 4, 5. All right, so we have a vertical asymptote at x equals 3. So where x equals 3, we have a vertical asymptote. And a horizontal asymptote at y equals 1. Now again, we don't know what's happening on either side of this vertical asymptote, but we can figure that out. If we go to the right, maybe 1, 2, 3, 4, because 3 won't work, let's go 4. So I'm going to say g of 4 excuse me. If we plug 4 in, we would get 4 squared minus 4 over minus 6. 16 minus 12 gives us 12. 16 minus 10. So we get 2. So g of 4, we got 2. 1, 2, 3, 4, comma 2. So it's going to go through this point. And so what we know, so again, I did the g of 4 quickly here and got 2 as an output. That means if we plug in 4, our function crosses at 2. And so our function looks like this. There. Now we can also figure out what's happening on the other side. Let's say we plug in 0. G of 0. And if we do that, we would get negative 4 over negative 6, or just, if you simplify it, 2 over 3. So g of 0, we look at 0 here, it's gonna end up being our value, our output is 2/3, which is here. So it's going to cross through that point and essentially do something like this. So that's how our function would behave. So I guess the key piece is we have to get our asymptotes first. That's going to give us a clear picture of what our function behaves like. And then we can plot points to figure out what's happening in each panel, if you will. I'm going to go to the next video here for time. If you have questions, please let me know.